Hi, welcome to this lesson on trigonometry, trig identities, part 1. Let's have a look at question 5. We asked to prove the following identity and state any restrictions in the interval 0 to 360 degrees inclusive, if there are any. Okay, so I have a left-hand side and a right-hand side, and by first glance, the left-hand side definitely looks more complicated than the right-hand side. So my technique here is to start off with the left-hand side, simplify it algebraically using well-known trigonometric identities, and then show that it's equal to the right-hand side. Okay, so let's write out the left-hand side, and I have two terms in this one bracket times a cos x term on the right-hand side. So before I do anything, I want to simplify that brackets. So I'm going to have cos x over sin x, and then tan x, I know by the quotient identity, is sin x over cos x, all times cos x. Okay, and now I can LCD, so I can get an LCD of sin x cos x. So if I combine those two fractions together, sin x cos x, what do I need to multiply the cos x term by to get sin x cos x? Well, I need to multiply it by cos x. Plus, and then the sin x here, what do I need to multiply that by to get sin x cos x? I needed sin x. Okay, so that's the term in the brackets times cos x. And then if I multiply that out, I get cos squared x plus sin squared x all over sin x cos x times cos x. And then I can see from here that I have cos squared x plus sin squared x. That is the famous trigonometric identity, sin squared x plus cos squared x equals 1. So I have 1 over sin x cos x times cos x. So this cos x will divide into that cos x, and I'm left with 1 over sin x. And that is the right-hand side. Okay, so we've shown successfully that the left-hand side is equal to the right-hand side algebraically. Now we just need to find any restrictions. So again, I can see for restrictions, both sides have fractions and a tan. Okay, so I need to note for all of those. So I'm going to start with the right-hand side restrictions because they are far simpler. The sin x term, when that's equal to 0, then we have division by 0, and that's an issue. So again, if we think about classic sin x graph, 0 degrees, 180, 360, and so on, every 180 degrees, there's a 0. So x equals 180 degrees times k, where k is an integer. Next, for the left-hand side restrictions, I have a cos x over sin x. So when sin x is 0, that's a problem. And then tan x here, when tan x has a problem, that is when x is 90 degrees plus k times 180 degrees. Those are for the asymptotes of tan. Okay, so the sin x equals 0, we've already solved for that. So we just need to look at this one here, which we've solved for as well. Okay, so now I'll put my k values in, and I note when do I get values in this domain. So when I put k equals 0, I get x equals 0 degrees. That's in the domain. K equals 1, I get x equals 180. K equals 2, I get x equals 360 degrees. Okay, those are the only ones because any other k integer value is going to give us values outside that domain. Similarly here, if k is 0, then I get 90 degrees for x. If k is 1, then I get x equals 270 degrees. But any other value of k is going to give me values outside that. Okay, so there are the restricted values. So therefore, x cannot equal 0 degrees, 90 degrees, 180 degrees, 270 degrees, and 360 degrees. Okay, so those are all the restrictions, and that's how we would solve this type of problem. Awesome. I'll see you in the next one.